What do we know about a line? There's a lot of things we know about a line, especially one that is in slope-intercept form, which is in y equals mx plus b. Even if it's in standard form, we still know a lot of possibilities about this line, but many things that we automatically know. Number one, if it is a linear equation, it's a line. It's not a curve or anything, not with x squared or x cubed or anything like that. We know that this straight line is going to do several things. Number one, a straight line can be formed with a minimum of two coordinates. So if I have one point and I make another point, that tells me the direction of this line and I can graph it. That's one thing I need to know, and that's how this is going to help us solving for the x and y intercept. The other thing we know is if it is a line, we know that lines extend forever. They go on forever. And if these lines go on forever, they will do two things graphically. One of them, they will graphically always cross the y-axis. That's why, if they're in slope-intercept form, we already know the y-intercept is always some y value with an x value of 0. Here's how we know that's true. Number one, if I plotted this point up top here, and I asked students to say, what coordinate is that? They would tell me, oh, well, that's 0, negative 1. Okay. What about this point up here? Well, that's 0, 2. What about this point up here? Well, that's 0, 4. What about this point down here? 0, 1. What do all these have in common if they're on the y-axis? The x value is always going to be 0. So I'm going to use that information to help me find one of the coordinates of this line that I want to plot. The other thing that I do know that will happen is if I draw any line, I know for some point, even if I plot a point up here, when I draw this line with two coordinates, I know that my line will have a y-intercept, but it also has an x-intercept, meaning someplace that it crosses the x-axis. That's always going to happen in linear equations in this case. So, knowing that information, I'm going to use that to take an equation up here and then solve for my x and y intercept. So here's how I do that. I use the information that at the y-axis, the y-intercept, it's always 0, some value y. Now, if it's already in slope-intercept form like this one is up here, I know for a fact that my y-intercept right away is 0, 5. Now, I'm going to go through and prove that. Here's how I know that's absolutely right. In this coordinate, I have an x and a y value, meaning my x value is 0. If I substituted 0 into the equation of the line that I'm given, so this is 3 times 0 plus 5. I know that 3 times 0 is just 0. And then I also know that 0 plus 5 is 5. So therefore, that is verifying my y-intercept. That's correct. So if I want to plot 0, 5, I could. So I'm going to come up here. If I was graphing this line just with intercepts, that's the first point of my line. Now, obviously here, if I wanted to, I could write down the slope as 3 over 1. I could go up 3 to the right 1. I could also go down 3 to the left 1. Here's where it gets a little more complex. In solving for the x-intercept, that's where my line will actually cross the x-axis. And it's the exact opposite of what the y-intercept is. At the x-intercept, we don't know the x value all the time, but we absolutely know the y value. Here's how I know that. First, if I plotted this point right here, that coordinate is 3 to the right, meaning it is 3, 0. If I plotted this coordinate, that coordinate's 1 to the left, I know the x value is negative 1 and the y value is 0. If I plotted this coordinate all the way over here, I know that's 6, 0. What do all these have in common? I don't know the x value, but the y value is always going to be 0. So here's how we use that information to our advantage. In the equation we have up top, what I'm going to do now is solve for the x-intercept algebraically. And here's how we do that. I know the y value is 0. So in this case, I'm going to use the original equation, but I'm going to substitute in 0 for that y value right here and set it equal to 3x plus 5. And I'm going to solve for x. Well, we solve this like any other equation then. Subtract 5 from both sides because I want to get that variable alone. Therefore, the 3x will drop in. It's equal to negative 5. And no, this is not going to be nice and neat. However, when I divide by 3 from both sides, I get x is equal to negative 5/3. I'm going to keep it as negative 5/3, or if I really want to, I could divide it in there. I can make that a mixed number. Negative 1 and 2/3 is our x value. So therefore, our x-intercept is either negative 5/3, 0, or negative 1 and 2/3, 0. Now, is that a point that I can actually plot up here? Well, no, not really, but this is why it's good to translate between, and transfer, I should say, between our finding x and y intercepts, as well as using slope intercept form. Well, I could keep going down here, 3 and to the left 1, because that's the same as my positive slope here. Remember, we talked about a negative over a negative is still a positive. And then when I graph my line, here's how I know this actually makes sense. When I graph that line, I know it's not the straightest line in the world, but it does purpose. Where does our line cross its y-axis? Obviously, 0, 5, there's no doubting that. Where does it cross the x-axis, though, about? Pretty darn close to negative 1 and 2/3, 0. And actually, that is accurate because we algebraically solved for it. So here's where it really gets helpful to know how to solve the intercepts. You only need 2 points to make a line. And this is one where it's really very helpful, especially if you have something that is in a complex standard form. Obviously, 3x plus y is not very complex or in standard or very complex standard form. If we wanted to, yes, you could just rewrite, subtract 3x to both sides and say y equals negative 3x plus 6. We could do that. But let's say it's a really hard one. I'm like, I really don't know how to do that. Here's where the x and y intercepts help us. I know for a fact my y-intercept has some coordinate for the x value that's 0 and some y value. Here, and now I'm going to use that. In this case, I'm going to substitute in 0 for x. So I have 3 times 0 plus y is equal to 6. And now I know 3 times 0 is obviously 0. Do I need to write the 0? Well, no, I can just write the y because I know y plus 0 is just y. And y equals 6. Oh, well, that's easy. I don't even have to divide or anything in here because this is 1y. It's equal to 6. Therefore, my y-intercept is 0, 6. So now I can come over and plot 0, 6. Right up here. Exact opposite for the x-intercept. This time, I don't know the x value, but I know the y value is going to be 0. So I'm going to take the same equation, but instead of substituting in a 0 for x, I'm going to substitute the 0 in for y. So that would be 3x plus 0 is equal to 6, which obviously, and yes, you could write in a 1 if you really wanted to, but 1 times 0 is just 0, and therefore I have a 3x is equal to 6. Last step here is to divide by 3. So x is equal to 2. Therefore, my x-intercept is 2, 0. And I can come over and plot that coordinate as well. So there's 2, 0. I have 2 points. I can make that line. And now if I really wanted to make sure that this was right, if I really wanted to check this, I could go back, take this formula, or take that equation. I could rewrite it if I wanted to. I could go through and, as we already said, subtract 3x from both sides. So therefore, y is equal to negative 3x plus 6. I know, hey, my y-intercept did not change at all, so that was still good. And my slope here is negative 3 over 1. So that means I could just go down 3 from this point to the right one. Hey, that's making sense with what I have based on my line. So I hope that was a little bit more informative. I hope that showed you why we could actually solve for x and y intercepts, and it makes graphing actually a little bit easier.